What's the name of that book? Animal Farm?
Oh, yeah.
My wife told me that I wouldn't like it.
You wouldn't like it?
She said, if you don't like 1984,
I don't think, I didn't really like it that much. But it's like kind of the same concept. I don't think it's like
Is it depressing?
No, it's more like funny. But oh my goodness, okay.
Where's that?
Well, I was wondering if you could comment on that.
So, what? Are you curious? I have a. Okay, so I have a bag for you. Put my charge and my charger so I can charge my phone. Yep. So again, somehow I got my tools. And first they got together. And I did it, and look at that on my hands, there was some stuff incorrected. Battery awesome. I don't know. And I cleaned off, it was hooked up, and as far as my percentage, battery acid.
Maybe.
Like from
What broke?
like the outer shell of the battery.
That's better than acid. It's probably fine.
You can handle nerve damage this young.
I'm not gonna get nerve damage.
But will I get it?
It'll be a bit itchy for 2 days. Don't go worry about what to do. Your eyes on hands. Way too much. At least I assume that's what it is.
Yes, sir. My dad was always a dude back, so I got sick of hearing about him.
Oh, really?
I was an anti-dude.
Where's John?
All right, sorry. The no bells kind of throws me off a little bit here. Okay, so we do not have a test next class, but it's coming up the one after that, I believe. Yep, so Thursday of next week. So we've got today and next Tuesday. And on Tuesday, I've got some extra graphing piecewise functions practice for you, like I've been saying. But I felt like it might be smart to give you the review earlier and not the day before or the class before, just in case some of this stuff is harder for you than some of the other stuff. So this is your test review. All of this will make up 114. So I really just need to give you time to try some of this today and some time to ask some questions. So you go ahead and just start off with question 1 and keep going, and then here in a little bit I will interrupt and offer to go over any or all of the first page. And then hopefully by the end of class you'll have it done, plus you'll have all your questions answered that you need to. That's what we'll aim for at least. But we might fall a little bit short of that just because classes are just a tiny bit shorter today. But that's okay because we'll have some time on Tuesday too. Okay, so any questions about the practice today? Okay. Johnny. That's a 2, that's a 1, 2. And Jackson's the left. Actually, while you guys are working on the first page here, I will pull over the class videos to the website. So if oh, I already did. Never mind. Should already be there. Okay, so I think 20 minutes is going to be way overkill for the first 3 questions. I do apologize. Number 3 didn't print out the greatest, but I think you can read it okay. It's supposed to be a piecewise function. It's kind of like a computer font error there. So, but don't stop when you're done with the first page. Go ahead and keep going. But I will go over questions 1, 2, or 3 20 minutes from now. You're live. You need to grab the handout.
Yes, sir.
You may not be ready for that. You might need to work on your makeup work first.
You got the right things. You got the right things.
Johnny Jaden Romero.
I don't know. What was that? The X or Y? Oh, the slope. I think slope and
So they're working on this. You can choose if you think you remember some of this from last year. You're welcome to do it with us, or if you want to work on your makeup work,
yeah.
that's fine too. Whatever you think is going to be more useful for you.
Thank you.
That's fine. That's like ax plus by equals. Yeah. And how it splits apart. It's located in Pinterest. And both ones, lots of people have just looked at this sometimes. I'll just copy those stuff. You know what's telling me?
Okay, it's been 20 minutes, so as promised, give you your first chance to get some help, but again, I'm going to just stick to the first page for now. So, any of the 4 parts of number 1, number 2, or number 3, which of those would you like me to go over with you? Number 3? Okay. So, I don't know why, but when I send it to my computer here, the piecewise function didn't get messed up. So, if you just had trouble reading it because of how it printed, I totally understand that. But this is a function that's in multiple pieces. This is what we called a piecewise function. Okay, I'll come back to this. That's just a whole separate thing. But first off, it wanted us to graph this. So I should try to graph y equals negative x minus 2. So that's mx plus b, y-intercept, and slope. And like we did with the notes, I'll try to do these in separate colors for you to help you see where each part came from. But before you move on, it's only negative x minus 2 when x is equal to negative 2, that's a closed circle, and less than negative 2. So that would be stuff to the left, not stuff to the right. So from the first part of your piecewise, that's all you should have, what I have in purple. Okay, the next piece is x plus 2. Once again, mx plus b again. So I know the y-intercept is 2. I know the slope is 1. I can graph that line. But the restrictions over to the right say that I should only be keeping where x is.
Sorry, I'm just grabbing the side of me. Oh, you don't have none.
When x is greater than negative 2, so it should not include it. That should be an open circle. But that point was already hit anyway, so that's not really a big deal. And bigger than, or less than or equal to 2. So equal to means closed circle, and it was describing the values between these two. Not the stuff to the left of negative 2, not the stuff to the right of positive 2. Now again, this one technically doesn't matter if you left it an open circle because it was closed from the first line, so in the end the point is there anyway. Okay, to continue on, the next one's just a horizontal line. Y equals a number is always going to be a horizontal line. Here's y equals 3, the line where y is always 3. And we're supposed to keep where x is greater than 2, not equal to 2, so open circle. But less than or equal to 4. So equal to 4 would be a closed circle, and it's describing the values between those, not the values to the left of 2, not the values to the right of 4. So that in black is the third piece of the piecewise function. Okay, and of course if you can do 3, you should be able to do 4. It's just a little more work, but it's the exact same process. So the last one looks like it's in mx plus b format. So I know the y-intercept is 6, and I can use the slope to get a second point. So 6 is about here. Count down 3, right 4 for the slope. That's what negative 3 force x plus 6 would look like, but I'm only supposed to keep the part where x is greater than 4. Not equal to 4, so that would be an open circle, except that I already hit that point from my black line anyway, and greater. So stuff to the right, not the stuff to the left. Yes?
Wouldn't that one go through 8 at y equals 0? Just down 3 over 4.
Down 3, 1, 2, 3, 4. You're right.
Okay.
I just was being a little too sloppy, I think. So, I know you guys probably disagree because I see this a lot of times every year, but the reason why we insist on you practicing this skill in this unit, even though it's not necessarily the best fit, is you just don't get a lot of practice graphing and reading piecewise functions. But if you can graph these 4 things and you can read these inequalities to know what parts you're keeping, you know, a 4-piece piecewise function is kind of tedious, but it shouldn't be difficult. Okay, the other part that I said I would come back to, rewrite the first 2 pieces as an absolute value function with limited domain. So basically, they're wanting us to use these 2 and put them together as a piecewise function. So sometimes it was the purple line, negative x minus 2, and oh, I'm sorry, they already gave it to us as a piecewise. They want it as an absolute value function. So to me, this looks a lot like the absolute value of x, except the absolute value of x goes to the origin. This one has been shifted right 2. So to go right 2, I would need to do minus 2 from x. So this represents this. And then when it says limited domain, it's just because this doesn't go on forever, whereas this does go on forever. So this really only exists when x is equal to 2 or less than 2. So this was this part of the question. It's just the absolute value of x, but shifted right 2. The first 2 parts were. Okay, anything else about number 3 while it's still up? Again, if it was just that you couldn't read the paper very well because it printed it so poorly, again, I apologize. If I had caught that before it ran them all off, I would have stopped it, but I didn't want to print another 400 pages or something just to fix that. So,
how did you figure out the domain name?
This domain?
Yes, sir.
Okay, well this is just describing what I have highlighted here. So I'm just looking at this part. It goes as far right as 2, and it goes forever to the left. But
oh, okay, gotcha.
yeah, so you could also write it like that if you prefer. Same thing. Anything else about number 3? Okay. Anybody need to ask about any parts of 1 or 2? Although I can't really answer 2 unless we do all the parts of 1. But
Can you do D for number 1?
okay. Okay, so we need a couple of things to make the equation of a line, and regardless of what this says, I still always think that even if it wants something else, it makes sense to start off in point slope. Even if that's not how your final answer is supposed to look. So, memorize point slope, plug in a point into x1, y1, 0, 4, and then to finish, you just need to think about the slope. So since this is we want it to be perpendicular to this line, we want them to have the opposite reciprocal of this line. So I have no idea what this guy's slope is. That's why this form is not that popular. If I subtract the 3x over and divide both sides by -4, now I can see his slope is 3/4. So a perpendicular line would have to have the opposite This is positive, so opposite would be negative. Reciprocal, 3/4 becomes 4/3. Now, subtracting 0 doesn't do anything. So, I, of course, wouldn't leave that in, no matter what it said. And again, I can promise you we're not going to ask you to do this on the test, but I guess just for the sake of this, standard form is also known as the general form, so I showed that to you in your notes, but it's pretty old-fashioned. It's where you add these x's over, you put the number of x's first, then the number of y's, and then add the constant over. Number of x's, then number of y's equals the constant. So, again, I don't know why we even bother asking you that, but you don't have to worry about memorizing general/standard form. But you do need to know parallel lines keep the same line, perpendicular lines get opposite reciprocal lines. You need to see how I figured out the slope of this line by putting them in slope-intercept form. And then to make the equation, I think it's a big mistake if you're not trying to do point slope every time. So, okay, I don't know whose question that was, but has anybody got anything else about D?
Did you switch the x and y because it's perpendicular?
The switch the x and the y?
Yeah.
Well, I saw that this guy's slope was positive 3/4. So to make a line perpendicular to it, he needs the opposite reciprocal slope. The opposite means change the signs. Positive becomes negative. And reciprocal just means flip your fraction over.
I'm talking about like the red formula with 0.
No, that's just me being dumb. I should have plugged in the x value here and the y value there. I just did it wrong. Thank you for catching that. Okay, distribute plus 16. Okay, so I don't know. This could be your point slope. If it says point slope, or if it says it doesn't matter, distributing the negative 4/3 gives you in slope intercept. If it specifically asks for slope intercept, and then if it says standard form, I guess you could put the number of x's, then the number of y's, and set it equal to the constant. But again, you don't have to worry about standard/general form for our test. But I'm just trying to do what it says. Okay, did that clear up? Yeah, sorry, I plugged in the point backwards. Obviously, you have to plug in the x value for x1 and the y value for y1. And if you do it too quickly like I did, then you could end up missing it even though you know what to do. Now there is one thing, again, our test is not next class, it's the class after. But we did decide, well, actually I'll wait. I haven't heard back from Ms. Thomas yet, but I'll wait to be sure, just in case she says no. Okay, anything else from page 1? Yes.
How did you get 16 on that?
-4 times -4 would be 16.
Divided by 3.
Okay. Sorry, I guess my brain is shut down for the week. There we go. Is that okay now? So, again, I didn't mean to do that. I didn't mean to make either mistake. But if nothing else, this is where I say, you know, when you guys finish your test, if you have extra time, you should try to check your work. Just simple stuff like that. Just plugging things in wrong, distributing wrong. Everybody makes those mistakes, but not everybody does a good job of checking their work before they turn it in. So, okay, so if you're still working on the first page, that's okay. Although I wish you would have asked. But let me give you, I feel like page 2 doesn't have as much going on. So 15 minutes from now, I will ask for questions from 4, 5, or 6. But don't stop, keep on going. I just will give you a chance to ask from that page in 15 minutes.
What
figured everything out already though. But except for this. So I feel like this is point slope, but on the answer key it just says y equals 7, which this is just y equals 7. But then to solve that, that would take it out of point slope, so that's why I didn't do that. But
Well,
Is that
just the
not
fact
true?
that,
That's right.
no, I mean, both are fine. If you
Okay.
left this on the test, it's right. It just, since 0 times anything is 0, like,
Yeah.
it's just kind of like considered simplifying. And then because the slope is 0, we know it's a horizontal line.
Yeah.
And horizontal lines are typically in the format y equals a number, so I would
Okay.
accept either there.
okay, I figured that out up there. I just thought that was the
Or
correct
y equals
answer, so-
-7, yeah, right.
Negative 7. Thank you.
Hello? Okay, thanks. You're checked out, Mason.
It's got like 2, right?
was off just a little bit there. But you should have had plenty of time for 4, 5, and 6. So which of those can I help with?
6.
Okay, number 6. Okay, so when we talk about a linear function is a I'm not sure what term they're looking for there. Linear function is a linear function. Has degree 1. So linear is always like x to the first. A straight function. I don't remember what kind of wording we'd be looking for there. I can.
He said polynomial.
Oh, okay. It's sure. So it's kind of weird to call it a polynomial because I don't know. We just don't usually refer to linear as polynomial, but I guess that's technically true. Write an equation of the line that is not a function. Okay, well, there's a ton of ways you could do that, but I don't know. I guess I would probably just do a piecewise function and make sure it overlaps somewhere. Sometimes it's x, sometimes it's x squared.
Could you do like x equals a number? Like x equals 2.
That would also not be a function. Yeah, that's much simpler. Basically, anything that doesn't pass the vertical line test would be fine there. But yeah, vertical line would make much more sense. Okay, so if they're calling a linear function a polynomial, then they're definitely calling a polynomial function a polynomial. But quadratics have degree 2. So we're going to talk about this after this unit. We'll do one unit or one section on the fundamental theorem of algebra, but this is actually the fundamental theorem of algebra right here. Whatever the degree is, a linear function has degree 1, the quadratic function has degree 2. Whatever the degree is, the reason why we care about that so much is that's how many roots it's going to have. So every quadratic function is going to have 2 roots. Roots are like solutions, similar to zeros, but roots can be imaginary, whereas zeros kind of imply real numbers. Okay, so describe the roots in each words. This one has 2 real roots. There's a solution, the x-intercepts. This one has no real roots, but it has to have 2 roots because it's a quadratic, it's a parabola. So this guy has 2 imaginary roots. So I have no idea what his equation looks like, but if somebody gave me his equation and I did quadratic formula would give me i's and the answers. They would both be imaginaries. And sometimes you get the same root, you get one unique real root. That's just if your root repeats itself. So something like, I don't know, x minus 3 squared is like x minus 3 times x minus 3. So 3 solves it once, and 3 solves it a second time. So it only ends up with 1 x-intercept. So the real roots, the real solutions show up as x-intercepts. Imaginary roots, imaginary solutions do not show up as x-intercepts. That's what they're getting at there. Okay, so anybody for question 4 or anything on page 1 if I went too quickly?
And for 4?
Sure. 4 I don't know why I thought we did 5 too, but okay, 4 or 5 is fine. Identify the slopes and both intercepts of this, and do it without changing to slope intercept. So this was, again, I didn't make this worksheet, but this is actually what's called general or standard form, the one that you don't really need to know. And some people like general form because it's pretty easy to find x and y intercepts. It's set up that way. You still have to remember the algebra, that y-intercepts, unless you always have an x value of 0, whereas x-intercepts always have a y value of 0. But if it's written in general form, it's usually pretty easy arithmetic. If I plug in 0 for x, 6 times y equals 30, so y would have to be 5. And if I plugged in 0 for y, I would be left with 5 times x equals 30, so x would have to be 6. So some people like general form just because it makes the arithmetic a tiny bit easier to find x and y intercepts. I don't know. I'm not a big fan, but it's fine. Now, if you plotted these 2 points, then you could graph the line, and then you could easily find the slope from rise over run. He's going down 5 to go right 6, negative 5/6. Okay, is that enough, Aaron?
Yeah.
Okay. Okay, and then what about number 5 or any parts of 5 or anything from the front page I went too quickly over? Yeah.
Number 5.
Okay, so write a piecewise function that matches this graph down here. So I look at this and I see 1, 2, 2, 3, 4 separate lines. So if I wanted to write a piecewise function, it's going to need to have 4 separate pieces. So this is just backwards of what we've currently practiced. So sometimes it's this red line, and his equation would be y equals, oops, I already got the y equals here. His slope is 4/6 or 2/3, and his y-intercept is 0. So there's his equation in mx plus b. Adding 0 doesn't do anything, so I'm not going to keep that. But of course we need to put his restrictions, because he doesn't exist the whole time. He just exists on a little bitty part of it. So he exists when x is equal to 0 and bigger than 0, but only up to 6. And he has to be less than 6 because that's an open circle. Okay, the next part of the piecewise function is a horizontal line, y equals 6. This is what I have in black. And he exists between 6 and 8. Both sides are closed circles, so 6 included and 8 included. Okay, the third piece that I have in purple, let's see, the slope is down to right 4, so that's negative 1/2. And then personally, I'm going to back this up till I could see where it would have hit the y-axis. It would have hit the y-axis at 10. And this guy exists. I've already included 8 here, so I need to make sure I don't include 8 here. But when x is bigger than 8 and less than or equal to 12, and then that leaves this last piece that I have in gray, and I'll do this one backwards. I've already included x equals 12, so don't include it a second time, where the x is bigger than 12 but less than or equal to 16. And then his equation, I can do the slope by rise over run, down 4, right 4. That simplifies to negative 1. Now, you can do 2 things to find the y-intercept here and finish this equation. You can do like I did on a previous question, and you can take this slope, and it's negative 1, so I can try to go negative 1, negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. And maybe if you're careful enough, you can backtrack enough to figure out what the y-intercept is. Yeah.
If the slope is one, isn't like the y value be the same as like the x-intercept?
It would be, yeah, that's a good way to think of it. So the other thing I was going to say, I didn't even think of that, but you've got a couple points here. You've got 2 good points to pick from. So you could just temporarily plug in one of these points, like 4, 12. You know the slope is negative 1. And then if you're willing to distribute and add the 4 over, that would be another way to not just get the slope. Well, I guess you would need the slope for that, but also to get the y-intercept. So yeah, there's lots of different ways to go about it. You can either backtrack. You can realize since the slope is negative 1, if this was 16, this has to be 16. Or you can just make the equation and solve for y equals, and then you've got the equation. So they're all really just as good. I would just say the first one of the backtracking, you could kind of see that it gets a little sketchy because you need to be extra careful because it goes off the graph. But technically that should be fine too. Okay, and then just kind of a change here. Rewrite the first piece to make the function continuous. So remember, continuous means a nice smooth curve. There's no sudden jumps in the graph like this. So really what they're wanting you to see that is if you took this line and you just bump it up a little bit so that it fits here, what would be left behind is now continuous because there's no breaks in the graph. So instead of calling this 2/3 x, you could call it 2/3 x plus 2. If you bumped it up to, then it would be continuous. Yes?
Would making it like towards negative infinity work too?
Towards negative infinity?
Yeah, the red one.
This red one?
No, the 100. I just like keep it the same, but just change like the limits to negative infinity to 6.
Okay, but you need this to come up to here. You need this to connect to this. So you could also just change the slope, I guess, to do this. So you could do this, or you could say, let's keep the y-intercept 0, but change the slope to 1. That would work also. Just some way to move this to connect it is all they're wanting you to think about. They're just trying to give you some like questions from different angles, just get you to think a little bit. So okay, and then for the continuous function, they ask us to find some points. F of 14 means tell the y value when x is 14. I can see that from the graph. Negative 2, well, does not exist. It's not part of the graph. This function never existed at x equals negative 2. At 6, now this says for the continuous function, so that would be here when x is 6, y is 6, and 10. Okay, so based on this slope, it looks like when x is 10, y is 5. Now, I don't think this should be a problem, but I do remember maybe 2 years ago on the test we had some questions like this, and a good chunk of students didn't know what it was asking, and I can't tell you that the day of the test. You need to know that f of 10 means give the y value when x is 10. F of 6 means give the y value when x is 6. If that wasn't immediate to you, then you need to write yourself a note there, because that is certainly just an expectation that you know that.
Is that like it's not on the test review? Yeah. Like I know it's on that, but it's not on our paper.
On what? Oh, it's not on yours?
No.
I think it just got cut off.
Like it says to make up a story about distance and time to match the continuous piecewise function.
My mind's blown. I have no idea. I'm pretty sure it's the exact same file, but I don't know why that's not on there. Yes, you do need to know this. Technically, it was on section 1.1 worksheet 2, so we have talked about it. You don't have to add it to your review, but I would probably add it to your review if it's not something like you feel like you know. That's weird. I guess we must have adjusted one of these two at some point, and I just saved it as two different files. I have no idea how that happened, but okay. So if you guys would go ahead and keep on working here, please. We don't have time to take more questions today, but you still have about 10 minutes. So if you'd please try to get a little bit more done. Again, you will have some more time on Tuesday. I've got a worksheet where you practice graphing piecewise functions, but otherwise I can give you more class time for the test review and more class time to ask questions. Of course, the exception would be if this seems exceptionally hard, if this just happens to be a weakness of yours, it would probably be to your benefit to go ahead and do a little bit of it for homework, or at the very least look over it a couple times between now and Tuesday. Just start the ball rolling with your test review. But again, you don't have to have it finished by Tuesday. Just make sure that you're setting yourself up to be ready for the test by Thursday. I'm pretty sure this one won't be a 50-point test. I think it'll be worth a little bit less than that. It's probably going to be like a 30-point test would be my guess. I need to double check with I need to check with Miss Thomas, who also teaches pre-cal, because we have to agree on those sort of things. So.